The next speaker is the Dr. Youngjo of ETRI, and he's talking about he's going to talk about the 6G vision and enabling technology. Please join me. Welcome, Dr. Youngjo.
So, hello everyone, I am Youngjo from ETRI. I'm working with the Mobile Communications Research Division at ETRI. So in this presentation, I'm going to discuss our initial views on 6G vision and enabling technologies. This is the outline of my presentation. We'll have a brief look at the service trends that we think are relevant for mobile communication technology. Then I'd like to present our initial views on 6G with a detailed discussion on 6G research direction and usage scenarios. Then I'll briefly touch upon potential enabling technologies that we have in mind for 6G. Okay, here we'll have a look into services and service trends that are closely connected with mobile communications. And we think these services will play as key drivers for the evolution of mobile communication, in particular in evolution towards 6G mobile, which is expected to be commercialized around the year 2030. First one is autonomous vehicles, such as self-driving cars and drones and personal aerial vehicles. They are already having their appearance in the current generation 5G, but we think full realization of such autonomous vehicles will happen around the time frame of 6G. Coverage extension. The service coverage of mobile communication up until now has been mainly for urban areas. And in the future, the coverage will be expanded to include remote areas, extreme places such as desert, and non-terrestrial areas such as air and ocean. Energy consumption. Due to the increasing concern for global climate change and pollution issues, the importance of low energy consumption is increasing. And factory automation. This is one of representative verticals of 5G. We think the ultimate goal of factory automation is complete replacement of wireline connection with wireless connection. But this 100% replacement requires capabilities that go beyond the current technology. Extended reality. The key characteristics of extended reality is provisioning a real world and virtual world combined environment, where we can enjoy some realistic virtual experiences. So post-industrial revolution, we think one of the key features here is a cyber-physical system, and this is used to control physical processes in industrial applications. Digital twin. Digital twin is a digital replica of a physical entity, and communication networks provide interactions between virtual world and the physical world. Telepresence. In telepresence service, people can feel as if they are located at the same place, although they are positioned in different locations. For privacy and security, there is an interesting development of distributed ledger technology, such as blockchain, and information protection technology, such as quantum and homographic cryptography. Artificial intelligence. AI is now being applied for user-centric QoS management and self-optimization of radio access technology. In the future, we think even the design of an air interface can be based on AI. Robots. With the advancement of robotics, we will have robots that can engage in our life as a friend, secretary, even as a life partner. A social networking service, it will evolve from simple text, picture, and video clip exchanges to more vivid and live video contents with tactile interaction, thus enabling instantaneous, real-time group sharing. So in the previous slide, we tried to identify important services and service trends. Here we try to summarize the key aspects of these service trends. And at the highest level, we think there are two important characteristics in the service trends: the emergence of a variety of new verticals and increasing role of AI. The emergence of variety of new verticals, this trend is being accelerated by the fourth industrial revolution, where we see an increasing fusion of mobile communication with other industries, so resulting in a variety of new vertical services. And in 5G, the vertical services, representative ones, are now the factory automation and autonomous applications. And we are also observing AI is playing an important increasing role in these verticals. And we expect AI will become a key ingredient in dealing with extreme complexity in the future mobile communication systems and also in a variety of future services. So if we go a little bit deeper into more technical details, we think these are some key technical aspects of future services. The first, digital representation of everything. And second is connection and fusion of digital world and physical world. So for example, XR, digital twin, cyber physical system. These are the technologies dealing with the combination of virtual world and real world. So we can say that the communication networks, whether they are wired or wireless, need to provide real-time interaction between the virtual world and real world. Another technical characteristics is the increase of data traffic consumed by machines. This trend is already evident in many areas, such as industrial IoT, self-driving cars, robotics, etc. And the last one is the demand for broadband service at any place on Earth, so which would require wireless coverage extension into extreme places, such as desert, remote areas, and also non-terrestrial areas, such as air and ocean. Now I would like to share our views on 6G. First is about 6G direction. 6G direction, from our perspective, can be summarized as two parts: so overcoming the limitations of 5G and creating new paradigms of communication for AI. So regarding our limitations of current technology, we think that there are three major areas that need to be addressed and improved. The first is latency reduction in wireline networks. In 5G, radio interface latency was significantly reduced. That is 10 times reduction compared with 4G LTE. But the overall latency in communication measured by end-to-end latency is not much different from 4G LTE. This is mainly due to the fact that most of latency still occurs in the wireline networking. So we need to cut down the latency, not only in the radio link, but also in the wireline networking. The second one is going beyond the limits of existing technology for full realization of verticals. So again, industrial IoT autonomous applications are considered the main verticals of 5G, but the full realization of such ultra-precision services requires high reliability, low latency communication, and high precision positioning that go beyond the current technology capabilities. Thirdly, coverage extension into more vertical domain and into non-terrestrial areas. So up until now, the coverage of mobile service is mainly limited in the horizontal domain, so on the surface or near the surface of a terrestrial area. And we think a 3D communication can extend the coverage into more vertical domains so that we can provide mobile services for aerial vehicles. And recently, satellite communication is attracting a lot of interest. This is because the launching cost of low Earth orbit, LEO satellite, is being significantly reduced, and making satellite communication cost effective and thus promising in the future application. So the primary goal of satellite communication is to provide mobile service in unserved and underserved areas that cannot be properly covered by terrestrial networks only. So regarding new communication paradigms for AI, we are looking at the two areas. So one is enhancing and reinforcing AI applications by communication. In other words, communication provides services that can enhance AI. Among many other things, we think these are key technical areas that need to be addressed: distributed infra and mobile core technology for AI, and low latency, ultra broadband, absolute synchronization for AI. Another area is AI native networking. Mobile communication systems are increasingly becoming complex, and we can easily expect the 6G mobile communication will be even more challenging, dealing with extreme complexity, massive traffic volume, diverse devices, and diverse services. So conventional solutions based on algorithmic approach will face serious challenges. So in this regard, artificial intelligence can be a potential solution in dealing with the complexity and diversity of 6G. In 5G, AI was not considered in the initial design of 5G radio access, and AI started its application later on. So AI is not a built-in feature in 5G. In 6G, we expect AI can be an essential ingredient of radio access. So what it means is that AI can be considered in the initial phase of design and can be incorporated as an integral part of radio access. Now we discuss our proposal for 6G usage scenarios. We describe 6G usage scenarios using a new term called usage element. So we define a usage element in such a way that the usage scenario is provided as a combination of one or more usage elements. So usage element can be considered as cornerstones of 6G, characterizing 6G usage scenarios in terms of technology and service that 6G can provide with. So considering both service trends and technology development trend, we've come up with 6 usage elements, namely ultra broadband, ultra precision positioning, ultra high reliability and low latency, and ultra 3D coverage and ultra low energy and ultra massive connectivity. So our 6G usage scenarios can be schematically represented by a hexagonal cone as shown in this figure, where we place 6 usage elements at the vertices of the hexagon. So this is the 6G counterpart from our perspective to the famous usage scenario triangle of 5G. So in order to emphasize the importance of AI in 6G, we place intelligence vertex at the apex above the 6G vertices of the hexagon. So this intelligence vertex is connected with every usage element, so implying the nature of ubiquitous intelligence. So if we summarize the characteristics of our 6G usage scenarios, first is expansion and enhancement of 5G usage scenarios. And second is providing a new usage scenario as a combination of one or more usage elements among these 6 ultra usage elements that are defined here. Here we show some of 6 use case examples with indication of associated 6G usage elements. So for example, the use case in-flight broadband internet has 2 usage elements, ultra 3D coverage and ultra broadband. Now we show our proposal for 6G KPIs. There are 11 KPIs proposed here. Some of them, can be found in 5G, and some others are new KPIs that we like to introduce in 6G. First is the peak data rate, which is the maximum data rate for a UE, and the proposed requirement is 1 terabps, which is 50 times increase compared with 5G. Next one is the user experience data rate at 3D anywhere, so which can be considered as a minimum supportable data rate per UE, regardless of UE position. So which means that the system need to provide this target data rate, 1 gigabps for UE, regardless of UE position, as long as the UE is located within the coverage. Next one is mobility. We think 5G needs to support mobility of up to 1,000 km per hour. So as a mobility requirement, we like to introduce new KPI defined as spectral efficiency at a given mobility. The requirement is spectral efficiency of 3.3 bps per hertz at a mobility of 1,000 km per hour. Next one is vertical coverage, and we like to have a 3D coverage extended into a more vertical domain in 6G. So we introduce vertical coverage here as a KPI. The proposed requirement for this KPI is 10 km above sea level, which is roughly the flight altitude of airplanes. For positioning, we propose a localization accuracy as a KPI, and the proposed value is accuracy within 10 centimeters. This is considering the requirement of industrial IoT and vehicular applications such as self-driving and plotting. ETRI latency. This addresses the total latency of communication, including latency in wireless interface and wireline networking. So proposed ETRI latency here is 6.0 milliseconds at 1,000 kilometers. So what it means is that when two devices are 1,000 kilometers away from each other, one-way end-to-end latency should be within 6.0 milliseconds. So if we consider the propagation delay in the optical fiber, this requirement allows just 1 millisecond as a processing time. So it's quite a challenging requirement. So for air interface latency, our proposal is 0.1 millisecond, which is 10 times reduction compared with 5G. And for connection density, we like to introduce the volumetric connection density, since we like to have a 3D communication in 6G. The proposed value is 100 devices per square meter, and which is 100 times increase compared to 5G. Okay, so now I'd like to show some of the important enabling technologies that we have in mind for each of the usage elements. For ultra broadband, it is terahertz communication, and we are now considering a sub-terahertz band actually in the frequency range of 100 gigahertz to 1 terahertz. And for ultra-reliability and low latency, this is basically an enhancement of 5G URLLC and enabling time awareness for mobile time-sensitive networking. For positioning, what we have in mind is a cellular-based real-time ultra-high precision positioning based on positioning reference signals and massive antenna arrays and ultra-wideband. For 3D, ultra 3D coverage, we are looking at 3D communication based on integration of terrestrial networks and satellite networks. For ultra-massive connectivity, there are mainly two areas. First is the enhancements of traditional low-cost, low-power consumption, IoT. And second one is the support of new usage scenarios, combining massive connectivity with other usage elements, such as massive connectivity combined with URLLC, and massive connectivity combined with aerial radio access. And finally, for ultra-low energy, we think zero energy networking, utilizing energy harvesting and backscatter communication will be promising. Okay, so this brings us to the end of my presentation. Thank you very much for your attention.
Thank you, Dr. Go, for his nice presentation. And it seems like there's lots of interesting and challenging work for ETRI for the next 10 years to prepare the 6G. So it is not only Korea and ETRI that the research institutes are preparing for the challenging work for the 6G. So we have 3 more talks left, and then we are going to see International Research Institute, how they are preparing the 6G and the 6G and the challenging works.